Okay, Algebra 2, we're spending our second day in the exponents, and we'll deal a lot with the rational exponents, the fractional ones here. Let's look at these simple exponential equations. Now, what makes this an exponential equation is the variable is in the exponent, okay? 5 to the x is equal to 25. This one's pretty easy because you know that 5 squared. So this one, x equals 2. Now, 5 to the x plus 1 equals 25. You know the exponent has to be 2. So x plus 1 has to be 2 in order to make this work. Okay, that means that x is going to be equal to 1 for this equation. Now let's look at the next one. 5 to the x equals 1/5. Now the strategy here is I want to write both sides as powers of the same number. So on the left, that's 5 to the x. Now, if you keep in mind, 1 over 5 to the 1 is equal to 5 to the negative 1, right? So 5 to the x equals 5 to the negative 1. Well, if this is true, then these exponents have to be equal. So x equals negative 1. So you're going to have to know your negative exponents to be able to solve some of these guys. This one, just rewrite it, 5 to the 3 minus x equals, that is a power of 5, 5 to the negative 1. Now, set the exponents equal to each other, equals negative 1, then you're going to get x equal to 4. 5 to the 4 minus x equals 0. Now, just think about this. If I'm multiplying 5, how many times do I multiply 5 until I get a 0? Well, if you're multiplying 5 or dividing 5, you're never going to get a 0. So this has no solution. You can never multiply or divide by 5 and end up with a 0. Okay. This one, 5 to this power equals 1. Well, you know that it's 5 to the 0 is equal to 1, right? So that means that 3 minus 4/3 x has to equal 0. That means 3 equals 4/3 x. Multiply both sides by 3. 9 equals 4x. So x equals 9/4. So our strategy in these exponential equations is to get the same number on both sides. These are exponential equations because the variable is in the exponent. Now we're using the fact that if I've got b to the x and it's equal to b to the y, then those exponents have to match. So when I see something like this, I've got a 2 on one side and a 4 on the other. Can I write those as powers of the same number? Well, yeah, I can rewrite the left side as 2 squared equals 2 to the 3x plus 1. Now I've got the same number on both sides raised to a power. Those exponents must be equal. So 2 is equal to 3x plus 1. So 1 is equal to 3x. X is 1/3. Same thing here. I can write this as 2 equals 2 squared to the 3x plus 1. So this is 2 equals 2. So I have to multiply those exponents. 3x plus 1. And so the exponent over here is simply 1. So now I know that 1 equals 2. 3x plus 1. 1 equals 6x plus 2. So negative 1 equals 6x. X equals negative 1/6. So again, what you're doing is just rewriting both sides of this equation to have the same number on both sides. So if I look at this, 3 squared is 9. So I can rewrite this 3 to the x plus 1 equals 3 squared 4x minus 7. And now I get a linear equation. X plus 1 equals 2, 4x minus 7. X plus 1 equals 8x minus 14. So 7x equals 15. So x is 15 over 7. This is 4 to the negative 1 equals 4 to the 3x plus 1. Same number on both sides. Set the exponents equal. So what, negative 2 equals 3x. X is negative 2 thirds. 2 to the 3x. Remember, 8 is equal to 2 cubed. So this is 2 cubed, 4. So now I get 3x equals 12, or x equals 4. So if I look at this one, 81 is 9 squared. So this is 1 over 9 squared to the 2x, equal 9 to the 13 minus 5x. To get this 9 on the top, I just make the exponent negative. So now I've got the same number on both sides, set the exponents equal to each other. Negative 4x equals 13 minus 5x. So you're going to get x equal 13. This one, so 2 thirds to the 2x. If I look at the relationship, so 9 is what, 3 squared, and 4 is 2 squared. So that can help me. So I can write this as 2 thirds to the 2x equals, this is what, 3 halves squared to the x plus 1. All right, that's 9 over 4. But now I've got a 2 thirds and a 3 halves, so I just need to flip one of them. So write this one as 3 halves to the negative 2x equals 3 halves to the 2x plus 1. So now I can set them equal to each other. Negative 2x equals 2x plus 2. So 4x equals negative 2. X is negative 1/2. 4 cubed plus 4 squared over 5 is equal to 2x. Now, this is a challenging problem, okay? I'll go ahead and admit it. You can't add these together. They're not like terms, but I can factor out a 4 squared. Okay, now we did a little bit of this last year. We'll do more factoring in the next unit. 4 squared times 4 is how I get 4 cubed. And then 4 squared plus 1, that's how I get 4 squared over 5. So this number, so this is 4 squared times 5 over 5 equals 2 to the x. The 5's go away. And now you've got 4 squared equals 2 to the x. Rewrite that 4 as 2 squared. Squared equals 2 to the x. So x is 4. I pulled these from, this is the Algebra 2 EP problem, okay? So you can see it's a little bit more complicated. So if this is a EP problem, honors will get more complicated. Do the same thing we just did. Factor out 3 to the 100. So 9 to the x plus 1 equals 3 to the 100, and then 3 minus 1 over 2. And you see this is going to give you 2 over 2. That goes away. So you're going to have 3 squared x plus 1 equals 3 to the 100. So 2x plus 2 equals 100. 2x equals 98. X equals 49. 7 to the absolute value of x is equal to 1/7. Well, rewrite the 1/7. That's 7 to the negative 1. Can I take the absolute value of a number and get negative 1? So if I set these equal to each other, absolute value of x equals negative 1, you should know there is no solution to that equation. Okay, and that leads us up into the homework for this section. Okay.